right? Now, if we talk about the electronic configuration of actinoids, the actinoid series, it is radioactive in nature. All right, and the actinoids, it starts with the atomic number of 89. Okay, here as you can see, and end at lawrencium. Okay, with atomic number 103. Okay, so again they have 15 elements present between actinium to lawrencium. All right. Now, here, if we talk about the electronic configuration, electrons, they are filled in uh, 5f orbital. If we talk about their electronic configuration, electrons, they are filled in 5f orbital. Okay. And the actinoid, they belong to the seventh period. All right, and their electronic configuration is given here, and it is written as n minus 2 here. Electronic configuration for actinides we write as 5f 1 to 14 electrons, and then 6d with 0 to 1 electrons, and 7s2 orbital. All right. Now all the elements of actinide, they are radioactive in nature. So that is why it is difficult to study the actinoid elements. Radioactive have already defined that what is radioactive, what are radioactive elements. Radioactive means that their nucleus, it keeps on splitting. Okay. The nucleus is unstable and it keeps on splitting. That is why it is hard to study about actinoids element, right? Also, if we talk about the atomic and ionic sizes of the actinoids, actinoids, they also have larger size as like lanthanides, even larger size than the actinoids. Okay, so that is why their ionization energy is low and they show more metallic character. Okay, so due to their larger size, they face the actinoid contraction as like the lanthanoid contraction. So what is actinoid contraction? That is the gradual decrease in the size of the actinoid atoms, right? And that is due to poor shielding of the 5f electrons, right? So as like lanthanoids from actinum to lawrencium, there is gradual decrease in the atomic sizes of the actinoids, that is termed as the actinoid contraction, and this is due to the poor shielding of 5 electrons. All right. Now talking about the oxidation state of actinoids. Actinoids, they have the common oxidation state of +3, all right, as like lanthanoids. But for few of the elements, as we can see here, their oxidation state varies. All right. So we can say that actinoids, they have they have oxidation state that generally lies between +2 to +7, right? But common oxidation state for actinoids, we can say it is +7, and the reason for this, if the question arises that why uranium has why uranium exists in, generally the question has been asked in exam based on the oxidation that varies in actinoids as well as lanthanoid. Say if the question has been asked in exam about uranium, that why uranium, it exists, it has +4 or +5 or +6 oxidation state, but actinoids, they have common +3 oxidation state, right? So the answer will be based on the reducing agent, that uranium being radioactive, it is acting as reducing agent. Okay, so that is why by gaining an electron or by losing an electron, being a good oxidizing agent or being a good reducing agent, so based on that their oxidation state varies, right, as we did in the lanthanoids, right? Also, the actinoids, like lanthanoids in 5f orbital with 1 to 13 electron filling, they show mostly paramagnetic behavior, right? So 5f orbital, it shows paramagnetism till 13 electron filling, right? Because the electron generally remain unpaired, right? Next,